It was a dark and stormy night. Thunder crashed and lightning did strike, until bursts of electricity struck the tower, transferring all the glorious power. The woolly creature was brought to life, ending the mad scientist's struggle and strife. The creature raised its graceful paw. The scientist exclaimed, "Thank you, Ohm's law." Ohm's law is the relationship that describes the interaction between voltage, potential difference, current, charge per unit time, and resistance. To understand this relationship, we must understand what each of these components are. You can imagine the current as electrons, little units of negative charge. These electrons are flowing or moving through a wire. Hence, the current is defined as charge, Q, in coulombs, moving through a wire per unit time, seconds. The voltage is an expression of the electromotive force, the potential difference to move one unit of charge from one position to another. Hence, it can be understood as the force which pushes the electrons. Lastly, the resistance is the opposition of this. The resistance is an opposing force which stops the passage of electrons. Ohm relates these three quantities in a law called Ohm's law. Ohm's law states that the relationship between the current is directly proportional to the voltage and inversely proportional to the resistance, more easily remembered as V equals IR. Ohm's law has many applications in our modern world and forms a basis for our understanding of the flow of electrical current through a complete circuit. This knowledge can be utilized in applications where the electrical charge is generated, stored, or transferred to devices. To understand the mathematical interpretation of Ohm's law, let's do a quick hypothetical calculation. The mad scientist has been presented with a problem. He has connected a lifeless creature to an electrical circuit. He needs to generate enough voltage to overcome the resistance of the body to allow the current to flow and bring the creature to life. If the resistance of the body is 100,000 ohms and the current produced by the lightning strike is 2,000 amps, what would the required voltage be to overcome this resistance? Just asking for a friend. Now, if we look at the problem conceptually, we can identify that the relationship is V equals IR. We have a relatively large value of R, and we multiply that by a relatively small value of I. Hence, we get this. Om, Om, Om.